Good morning. We want to make some videos in order to be able to go through some of the topics that we haven't gone through. We won't go through every one of them, but those ones that are of importance. And one of the things that we want to look at is difference equations. Difference equations, or if you like, recurrence relations. Difference equations is a concept similar to that of, if you like, differential calculus. Which you have done already in other courses. Now this one has to do with change. This also has to do with change, but it is more associated with sequences. So, for instance, if you consider a sequence 3, 6, then you have 12, you have 24, you have 48. Clearly, you can try to find out what is happening here. How are we getting the? This is the first term. This is the second term. This is the third term. What is the relationship between the first term and the second term? What is the relationship between the second term and the third term? It's going in a certain pattern. And so if we assume, or if we define, if we say A naught is equal to 3, then we can define a certain recursive relation which will be able to help us to calculate each of these terms comfortably. We can even use that particular relation to calculate the 100th term very easily. And so we can write the relation in this form. Maybe this is a subscript. A subscript k minus 1 is equal to, or A subscript k is equal to, if you look at it, we are multiplying. See that if you multiply 2 by 3, you get 6. If you multiply 2 by 6, you get 12. If you multiply 2 by 12, you get 24. And so we can write it 2ak minus 1, where the k is greater than or equal to 1. So the k is a natural, if you like, a natural number. So our n, our k belongs to the set of natural numbers. So look at it. Once we set A naught is equal to 3, that's our first term. If we put k is equal to 1, if we pick k to be 1, it means we'll have A1 is equal to 2A naught. And what is our A naught? That is 3. And so you have 2 times 3, which gives us 6. So our this A0, this becomes A1, this becomes A2, A3, A4, and so on and so forth. And so if we want to find if k is equal to 4, it simply means we have A subscript 4 is equal to 2 times what? A3. And A3, we already know that to be 24. So that's 2 times. So this is equal to 2 times 3, which is equal to 6. This is equal to 2 times 24, which is equal to 48. And so you can keep finding. So it means that for you to be able to get A4, you need to know what A3 is. In order for you to be able to calculate A5 is not given here. So if we want to calculate A5, it means we need to know A4. And so this is what I call recurrence relation, or it's a concept we call difference equations. Difference equations. And you can, all this, you can find them in your, the references that you have been given. So let's look at the following remarks. The following remarks about the above example are in order. So we have the equation AK is equal to 2AK minus 1, or we can rewrite it in another form. We can rewrite this. If we don't want to say that this is A0, but we want to say this A1, A2, A3, A4, A5. We don't want to start with A0. What we are going to do here is that we would write AK plus 1 is equal to 2AK. So again, you get the same thing. So if the K again is natural. So if K is 1, it means you have A2, and A2 is equal to A1, and your A1 is already 3. So there's no straight or a strict rule. So it depends on you. Now the equation A0 is equal to 3, which gives a specific value to one of the terms, is called an initial term. So our A0, which we pick to be 3, is called an initial term. Or if we take A1 to be equal to 3, we call that initial term, or initial condition. Initial condition. Now the function, this may be different from what we have done already, so let me clean it. The function an equal 3 times 2 raised to the power n, which gives a formula for an as a function of n, not of the previous term, is called a solution of the recurrence relation. Now, what this thing that we have here, we're saying that it is called a solution. It's a solution to this recurrence relation because, well, now what we are getting here, if you know your n, you don't need the previous term to be able to calculate your nth term. So for instance, if you want to calculate where n is equal to 100,